Hi everyone, we're going to finish up our review for the unit test we didn't get to complete in class yesterday. We just had a couple more problems to go through. So we'll start off with problem number 9. And it says that we're taking this function f of x, and we're actually going to do two things. We are first going to do reflection across the y-axis, and then we're going to do a reflection across the x-axis. So we're actually doing two different things here. We have to do them in the order that it says. So the first thing we want to do is reflect across the y-axis. When we reflect across the y-axis, we are negating all of the x's. So when you have y-axis reflection, you are doing f of negative x. That means I'm replacing all of my x's with negative x. So I have negative x to the fourth minus negative x to the third minus negative x squared minus 2 times negative x minus 3. And we talked about this in class and we said, well, whenever your exponent is even, that turns a negative number into a positive number. If I multiply a negative number 4 times, it makes it positive. So whenever your exponent is even, this will then become positive. So negative x to the fourth is going to be the same as x to the fourth. Negative x to the third will still be negative, but I also have this negative in front. So now I have positive x to the third. Over here I have negative x squared. That's an even exponent, so that will become positive, but then I still have this negative in front. So this is negative x squared. This negative times this negative becomes positive, and then that constant term stays as it was. So this is now the reflection across the y-axis, and now I need to do part 2 where I'm going to take this new function and reflect it across the x-axis. Excuse me. When you sorry guys. When you reflect across the x-axis, that means you take your function and you negate the entire function. So I end up taking this entire function and negating it. And all that means is that I multiply the entire function by -1. So all I have to do now is distribute that negative. So it said to use g of x as our new function, and now I'm just going to distribute that negative. So I have negative x to the fourth minus x to the third plus x squared minus 2x plus 3. So all I did was distributed that negative, and that's my final answer for that one. So just make sure you're aware of the two different things depending on which axis you're reflecting over. Okay, and then the last one is to use finite differences to determine the degree of the polynomial that best describes the data. This was from last Friday. We didn't actually have a live session on this, but it's pretty straightforward because you've kind of done this already. Back when we worked with quadratic models, we said that second difference had to be constant in order for it to be quadratic. In this case, you're going to keep finding differences until they're constant, and then you can determine the degree from there. Okay, so we'll walk through it. The first thing you want to do is make sure that your x values are changing at a constant rate. So they're increasing by 1 each time. As long as that's the case, then we can go through and figure out what our degree of the polynomial is by finding our differences in our y values. Whenever you're finding differences, you are taking the second one minus the first one. So I'm doing -3 minus 15. So the difference here would be -18. Difference here, -1 minus a -3. Okay, you have to make sure you do this in the right order. That would be 2. Here I have -3 minus a -1. That would give me -2. Here I have -9 minus a -3. that would give me -6. Here I have 5 minus a -9. 5 minus -9, which gives me 14. And here I have 87 minus 5, which gives me 82. Holy cow, there's a lot going on there. Okay, clearly these are not constant. That was my first difference, so now I have to go ahead and do my second difference. I'm going to do the exact same thing that I just did. I'm taking that second number and subtracting the first one. So 2 minus -18 gives me 20. -2 minus 2. So -2 minus 2 gives me -4. Here I have -6 minus -2. And that gives me, whoops, there, that gives me -4. Here I have 14 minus -6. That gives me 20. And here I have 82 minus 14, and that gives me 68. Okay, again, I don't have a constant difference. I have all these different things going on here. So now I'm going to go down to my third difference. I have to keep going until I get something constant. So again, I'm taking differences. -4 minus 20 gives me -24. 20 minus a -4 gives me positive. Oops, I forgot to do these. Sorry, -4 minus a -4 gives me 0. Then I have 20 minus -4 gives me 24. And then I have 68 minus 20. 68 minus 20 gives me 48. Still, I don't have a constant, so now I'm going to go ahead and do my fourth difference. So I'm taking the difference here. 0 minus -24 is 24. 24 minus 0 is 24. 48 minus 24 is 24. So I have this constant difference. I'm down at my fourth difference, which just tells me I have a fourth degree polynomial, and that's the answer that I'm looking for. I don't need any special name or anything like that. I think they use names like cubic and quartic and all those different things. I don't need that. Just give me the number. So fourth degree polynomial. That's the answer that I'm looking for there. Okay, that's pretty straightforward. I believe there are a few other problems on the review sheet that we didn't go over. You don't have to worry about those. Those are not going to be on your test. Your test is pretty straightforward. It's 10 problems, 35 points. We reviewed most of the problems in class yesterday and on this video. Like I said, it's pretty straightforward, and I think you all can do really great on the test. So good luck on the test. Not that you need it, because you all are fantastic. Have a wonderful Thanksgiving, and I won't see you next week because I'm away at testing, but don't forget there's a big surprise coming next week. All right, everybody, have a great day and a really nice holiday. I'll see y'all later. Bye-bye.